Alright, so now we've gone ahead and split our jobs into stages. And we've defined two stages, a greeting stage and a build stage. It seems like the next thing we should do is start thinking about our entire pipeline, our entire chain. And so what we want to do is start actually skimming, doing something with this thing that we've compiled, the skim.cxx. So let's go on to the next step, our skimmer Higgs. So we're gonna go ahead and just be a little bit naive. So I know we need to do two things. I know we need to add a run stage. So if I go to the GitLab YAML file, we'll add a run stage. And in this run stage, we're gonna go ahead and add in a skim ggh job. I think for now, I just want to be able to run this skim binary that we created from build skim. So let's try this now. Alright, so let's see what happens if we just run this. Add skim ggh job to run stage. And we'll run this. And we should see the pipeline update, but I'll refresh. There we go. We've got our 3 stages. So let's go ahead and let this run to double check that things work. I already know that this is going to fail, by the way, but we should go ahead and look at this failing first, just so we understand how it fails. So we just have to wait a little bit. Maybe refresh. Let's peek on the previous jobs here. How's build skim doing? Build skim finished. So it looks like build skim latest was still running. And yeah, hold on, we're just taking a little bit of time to pull those Docker images. The Docker images are pretty bloated with these root installations. Alright, let's see here. Any second now. Any second. Come on. I guess I am a little bit impatient here. There we go. It uploaded the artifact, which is great. So let's go ahead to the run stage. Let's see what happens. This should run pretty quickly. And there's the error. And okay, so there is no skim binary. So the problem here is that we're not pulling artifacts from the previous job. As you can see here, this downloading artifacts line, there's no artifacts being downloaded. So we probably need to set up artifacts. I will link you in the tutorial more about job artifacts. But by default, artifacts from all previous stages are passed in by default. But we should also define dependencies, because dependencies tell us which artifacts to pick up. I have a lot more information about what we can define with artifacts that you can read through on your own time, such as specifying the paths, the name, whether to use all untracked files or not, when to upload artifacts, when they expire. And there's also this weird thing for unit tests, which I've never really used before, so we're not really going to cover it in the scope of the tutorial. So let's go ahead and add these artifacts to save everything. So let's see how we do that. So looking at this GitLab YAML file, we're going to go ahead to this build template here, this hidden job, and I guess under the script, we're going to specify artifacts. We're going to specify the paths, the skim binary that's being created, and we want these to expire in 1 day. So that looks good. Now the last thing we need to do is we need to tell skim GGH to only get the artifacts from build skim and not build skim latest. So we need to define dependencies or declare them. And we declare the build skim job as a dependency for skim GGH. Alright, so let's go ahead and do this. GitLab stage, and okay, this looks correct. Artifacts and dependencies. Alright, so this should hopefully run a little bit faster than the last time. Let's go back to the branch, which doesn't help. Let me find the merge request on the left and click that. There we go. Pipelines. Alright, hopefully this runs a little bit faster. And I guess I have a little bit of time to talk about artifacts. So, you know, these artifacts are very useful. They can be pretty much anything you want. You can imagine, for example, if you realize that you've compiled something and you don't necessarily need the rest of your code in a downstream job, but you only need the compiled binary, then you don't actually need to clone the repository anymore at that point, and you can just start passing around artifacts. So you can start thinking about how to make these jobs run faster and faster and faster by being very picky about what you clone or don't clone. You can also think of artifacts as pretty much anything that you want to upload after all the jobs are done. Because if we go back to all these pipelines that you have here, you can't necessarily see it unless I make this bigger, but if I click on this, sorry, that's not what I wanted to click on. If I click on the pipeline, that was an accident. If I click on the pipeline here, let's see, there are no artifacts to find here just yet. So I should be waiting for the job that added artifacts and dependencies. So I just need this to, that's finished. So here you go. You can see this download button here that allows you to download artifacts for the individual job. This will be very useful. So let's go ahead and see, that still failed. Alright, let's go ahead and check out what happened here. Shared libraries. Did we have root in this image too? No, we didn't. Okay, so the other problem here is that we forgot to use the same image that we used for the build job. Because in order to run a binary, you need to have the same shared libraries that you compile with. Alright, so I guess in the skim GGH, we just need to add in the same image that we want to use. So let me grab that here. Build skim, I'll copy it from build skim, and I'll add it after, I guess, dependencies. Alright. Use root image for skim GGH. Okay. So hopefully that should work now. I'm pretty confident that should work at this point. So while this is running in the meantime, let's go ahead and talk about actually using a root file to run this skim binary on. So let's see what I have in the tutorial. Now I should mention the tutorial was originally written specifically to CERN. So we are going to use, for pretty much anybody who does not have a CERN account, we are going to use the EOS public.cern URL here. But so I should mention that there's a lot of different ways that we could be getting data into the CI. So we could get the entire root file that we want to run on every time. We can go ahead and git commit that root binary into the repository, but again, we want to avoid repository bloat if we can. Or maybe we can make a smaller root file, but it's going to be a lot of work every single time. So what we like to use is perhaps XRDCP, but for root files, we generally tend to use what's called XRDCP, which allows you to use root's xroot protocol to effectively stream or download a file, especially root files in the long run. So nicely enough, we have these data files on EOS in the public EOS space. And there's a lot of different ways that we can figure out how to map it correctly. But so if I went ahead and used my XRDFS right now, I can see that in here we have a lot of different root files showing up in this space. So what I want to do is go ahead and pour an added xrootd path here to streaming this input file. So I'm going to go back in here because I know how the skim binary works because we looked at the previous tutorial videos on this. We're going to go ahead and specify the public path here, which is eospublic.cern.ch. So first, we need to specify the root protocol, then eospublic.cern.ch. Double slash, then we need to do, let's see here, this path, sorry, it's not a double slash, it's a regular slash, but we'll add in and copy this path here, eos, root eos, Higgs, tau, reduced, and then we're going to go ahead and grab the glue to H, because that's the GGH that we want to use. And we also need to add in the extra information that we got from the previous tutorial, 467.0.0.1. Which you can see down here if I scroll over. I should have scrolled, sorry about that. Now, you note that in this particular command, I'm using my particular EOS base from the awesome bootcamp where this tutorial was written for. But we're going to go ahead and use this EOS public path instead. Hopefully people can see this, pause the video and type it in, but it should just work for you. So we're going to go ahead and save this. Double check that we're adding the right. That looks right. Let's run on an actual root file. And let's push that. Alright. So we can see here, interesting, this root image failed. So we can go ahead and see how that failed. So it looks like what we did in the previous time is that it needs an input file, an output file, which we forgot to put, the cross section, the integrated luminosity, and the scale. So let's go back and look at the YAML file that we have here. We specified this input, but whoops, it looks like we forgot. Oh, maybe I forgot to specify the output here. Because did I put that in the tutorial? Yep, I did. So this is just Jordan being an idiot. Alright. So we're gonna go ahead and add that back in. Specify output root file. And push that. And hopefully that should work. So let's double check that this is added correctly. Alright, so this pipeline here, this second one in the list, will probably fail because we didn't specify the output file. So I'm hoping for this first pipeline on the list here to succeed. While we let that run, let's go ahead and talk about how many events we want to run over. So for CI jobs, at least at CERN, we use the concept of shared runners. So everybody has some sort of notion of shared computing time. For the most part, CI jobs can run at most an hour because that's a limit set by the CERN information technology staff. However, I generally like our particular job to run in, no more than 5 to 10 minutes probably. Fast turnaround time is much better and it's much easier for you in terms of development. You want to be able to get yourself a cup of tea or a cup of coffee out and then come back and see that the jobs are finished, and allows you to sort of reiterate and constantly develop. And because for some of you, because you're using the EOS public, you will not be getting an error, hopefully. But let's see what happens if we use the EOS public right now. And it looks like the build stage is still going on. So, as I mentioned, for the number of events, it really depends on the analysis. Some analyses can process 100 events a second. Some can do 1 event a second, especially when you're doing event generation, which could be maybe an event a minute, which could be very slow. I like to say that you want to process enough events such that your CI job are meaningful. It doesn't really make sense if you have an analysis that has a 1% selection efficiency and you only run 100 events, because that's not going to give you enough statistics to figure out if there have been physics changes. So you want to have perhaps maybe 10,000 events in that particular case. But let's say you have a job that has a, 50 to 70% efficiency, but you could do with less statistics at the end of the day. Alright, so where are we with the skimming? Okay, looks like the skimming is running, so let's peek in and see what that one is doing. So it's pulling the Docker image in now. So hopefully we should see it passing, or maybe it'll fail with some sort of permissions error. And look, it says it's processing the input, which is great. And there's 47,696 events in there. And it looks like it ran. Great. So there's not much more that we need to do. For those of you following the tutorial and you run into the permissions error, this won't be covered in the tutorial videos, maybe. However, for those of you running on EOS Public, you can proceed to skip to the next video of what to do next. However, for those of you getting the permissions error, you should go on to the next video and we can talk a little bit about variables. For those of you who want to learn a little bit more about variables, go ahead to the next video as well.